So again, for first sem, 12th class first sem exam with new topic, I am here. Electric potential and potential energy. Electric potential and potential energy. Some of you were complaining in videos that clarity, you want clarity on the board. So please see in high frequency, then you will get clear video. I have very simple mobile that have simple camera, and that I am making a video. Right? So when you see that through high frequency, then you will get each and everything clear. So please do it by this. Electric potential and potential energy. You all are familiar about the term gravitational potential. Gravitational potential in 11th class, you all studied about gravitational potential. In same way, here we are going to talk about electric potential. If some of you know what is the definition of gravitational potential, then you can recall that the amount of work done in bringing any unit mass body from infinite to point inside the gravitational field is known as gravitational potential at that point. Why I am telling you this? That by that you can recall. You can connect this definition with that definition. I am going to tell you electric potential definition, but very first I want to tell you 11th class definition. I think most of you know that the work done in bringing unit mass body from infinite to point in infinite means very far. Any unit mass body you are taking from very far to point inside the gravitational field. Then you do a work. That work is known as gravitational potential at that point. In same way, electric potential. Again, see here the term mass is changed by charge. Work done in taking unit charge. Work done in taking unit charge from infinite to point inside the electric field. Point inside the electric field is known as electric potential at that. Infinite means very far. You are taking unit positive charge from very far to point inside the electric field. That is known as what? That is known as electric potential at that point. Potential V equal to W upon Q naught. Electric potential V equal to W. What is W? Work done. What is Q naught? Test charge. Test charge we always show by Q naught because it should look different. We use that for test. We want to check how much potential at this point. For that what we did? We taken that charge from infinite to that point. Then the work done by us is equal to electric potential at that point. As you know, unit of work is joule. Unit of work is joule. And while the unit of charge is coulomb, joule per coulomb is the unit of potential, electric potential. Electric potential of unit joule per coulomb, which is known as volt. Actually, what is work of electric potential? You should understand. Electric potential determines the direction of flow of charge. As you know, water always flow from higher potential from high to low, up to down. ऊपर से पानी नीचे के लिए flow. Water is flowing from up to down. Similarly, electric current is always flowing from higher potential to lower potential. Electric current is also flowing from, it means electric potential determine the direction of flow of charge? Direction of flow of charge. Positive charge always flows from what? Higher potential to lower potential. Negative charge from lower potential to higher potential. Electric current from higher potential to, because so electric potential determines the direction of current. जैसे कि वाटर अप से नीचे के लिए फ्लो करता है अप टू डाउन, सिमिलरली करंट इज आल्सो फ्लोइंग फ्रॉम हायर पोटेंशियल टू लो. व्हाट इज मीनिंग ऑफ हायर पोटेंशियल? सी हियर आई एम राइटिंग प्लस 10 वोल्ट, right, minus 5 volt. It is very clear. Plus 10 volt is higher potential, minus 5 volt is lower potential. If I write 0 volt, 3 volt minus, so 0 volt is at higher potential, minus 3 at lower potential. If I write minus 5 volt, minus 8 volt, minus 5 is at higher potential, then minus 8. So I hope everybody understand these facts. So it is clear for everyone that V equal to W upon Q naught, unit is volt. You can find out the dimensional formula also. I think most of you forget dimensions and all. You completed dimensional analysis in 11. So that I am going to tell you. Volt. W have unit joule. W have unit joule. That is one. And coulomb, the unit of charge. Now joule can be written as Newton meter. Newton meter. And coulomb can be written as I into T. Charge, you know, charge can be written as I into T. I means Q can be written as I into T. I means current. What is unit of current? Ampere. And what is unit of time? Second. So Newton meter ampere per second. What is dimensional formula for force? Can you recall that? I think most of you forget that. M L T minus 2. This is dimensional formula for force. Newton is the unit of force. Newton is the unit of force. And meter L A T M L square T minus 3 A minus 1. This is dimensional formula for potential, electric potential. Electric potential dimensional formula. I hope you all understand. Now you see here another term I written, potential difference. Very common thing. Difference in potential. Suppose that you have a conductor. Here potential is 10 volt. Here potential is 8 volt. I ask, what is potential difference? Very common, 10 volt minus 8 volt. It means 2 volt. So what is potential difference? Difference in the potential across the ends of conductor is known as potential difference. Difference in the potential across the ends of conductor is known as potential difference. Another definition I can give you. Same way. Work done in taking unit positive charge from one end of conductor to other end of conductor is known as potential difference. Work done in taking unit test charge from one end of conductor to other end of conductor. यूनिट टेस्ट चार्ज को कंडक्टर के एक एंड से दूसरे एंड तक ले जाने में जो हम वर्क करते हैं That is potential difference. Why we do work? Because there is difference in potential. If potential is same between 2 points, suppose that both points are potential 10, then work done is 0. Potential is same, right? Work takes place because of potential difference. Work done in taking unit positive charge from one end of conductor, so that you can write here delta V potential difference equal to W upon Q naught. Unit is again volt. Dimensional formula is also same. I hope you all understand. Another term I written electron volt. Now what is electron volt? Actually it looks that electron volt is something related to potential difference. No, it is unit of energy. Electron volt is unit of energy. That I can clarify you. As I told, V equal to W upon Q. Already told. V equal to W upon Q. So what is W equal to? VQ. VQ. Now W, work. What is that? That is work. So work always stored in form of energy. Just now you are listening my video, watching my video. You are increasing your physics knowledge. You are increasing your physics potential. So this is your energy. Work stored in form of potential energy. So here W equal to V into Q. If in place of Q, Q means if electron is there. What is there? Electron is there. What is charge on electron? Small e is the symbol of charge on electron. Then you can write EV. EV. So EV is known as electron volt. That is unit of energy. That is unit of when an electron is accelerated by 1 volt potential. You have an electron, you accelerate that by 1 volt potential. Then the energy gained by that is known as 1 electron volt. You have an electron, you accelerate that by 1 volt potential. कोई इलेक्ट्रॉन है आपके पास, आपने उसको 1 volt potential से एक्सलेट कर दिया. Then energy gained by that is known as 1 electron volt. I hope you are understand. Now after this all, I am at a very important derivation for first semester exam. For first semester exam, electric potential due to a point charge. Suppose that you have a charge Q. You have a charge, again I am repeating, please see my video in high frequency. 350 frequency, 360. What? 360 quality, then you can see each and everything crystal clear. It's my promise. Please see it nicely and utilize it. Right? That is my motto, that you all understand physics easily. You all will become good in physics. So just now I am going to tell you very important derivation for your first semester exam 2022. It will be in 2022, I think. Yes, in September approximately. So now, you have a charge Q here. Due to that, what I am going to do, I am going to derive an electric potential due to a point charge. This derivation I can do by 2 methods. One by integration method, other without integration. Both methods I will try. Very first I like to share with you that you have a charge Q. Due to that you have to find out potential at point P, which is at small r distance. Let you have charge Q. Due to that you want to find out potential at point P, which is at small r distance. What you like to do for that? You take in two other points. One is A, other is B. A point at x distance from charge Q. भाई आपको ड्यू टू चार्ज q पोटेंशियल पॉइंट p पे फाइंड आउट करना था. What you did, you taken two other point A and B. A point is at x distance from charge q, and between A and B there is a distance dx. There is a distance dx. At point A, you put a test charge q naught. भाई अब हमें पोटेंशियल निकालना है तो चेक करने के लिए एनी चार्ज एनीथिंग वी विल टेक. So this is test charge q naught. You put it at point A. And when you put that test charge q naught at point A, as I told you all Coulomb's law, first chapter, Coulomb's law, you all know what is Coulomb's law. When two charges are kept at a distance, then an electric force acts between them. Right? So here two charges, one is q, other is q naught. They are kept at distance x. They are kept at distance x. Then a force will act between them. Here is two charges, one is q, other is q naught. Q naught is test charge. So force acts between both the charges. That force is F equal to 1 upon 4 pi epsilon naught q naught upon x square. This is force. This is force acting on. This is force acting on q naught charge due to charge q. Due to charge q. Right? What like to do now? You like to take this charge q naught from A to B. A to B. What you did? You taken charge q naught from A to B. When you take it from A to B, you will work. Why you will work? Because these charges are repelling each other. These charges are repelling each other. Force is acting outward. Electric force, because both have positive charge. So both charge will repel each other. Both charge will repel each other. And you want to take this charge q naught from A to B. Then how much work you will do? dW. Why I didn't dW? Because we are taking very small distance between A and B. dx. For small distance displacement, small work is done. भाई छोटे अगर डिस्प्लेसमेंट होगा तो छोटा वर्क. नाउ हाउ मच वर्क? F into minus dx. F into minus. Why I written minus? Because force is acting outward and displacement is inward. The direction between force and displacement is just opposite at 180 degree. जब फोर्स और डिस्प्लेसमेंट एक दूसरे से 180 डिग्री पे होते हैं, then work is negative. Displacement is opposite to the direction of force. That's why I taken minus dx. That's why I taken minus dx. Now I can put the value of force here. 1 upon 4 pi epsilon naught q naught q. You want to put k here also, you can put k for the medium, if dielectric medium is there. q naught upon x square dx. Minus will come here. Minus will, but it is work from taking from A to B. But what we have to find out? We have to find out potential at point B. For that, what I have to do? I should take this charge q naught charge from infinite to point B. I have to take this test charge q naught from infinite to point B. Just now what I did? I taken this q naught charge from A to B, very small distance. That work we find it out. But we have to, that is not potential. For potential we have to find out work done in taking unit positive charge from infinite to point inside the electric field. So q naught we should take from infinite to point B. So total work done, integrate both sides, and integration limit if you see, you are taking from infinite to point P. So lower limit is infinite, upper limit is R, and minus will come here. 1 by 4 pi epsilon naught k q naught x square dx. Now W equal to minus 1 upon 4 pi epsilon naught K Q naught. You can take common outside the integration sign. Why you taken this all? And 1 by x square you can write x power minus 2. Why you taken this as outside the bracket? In this way you can write Q naught. Because integration will take place only which have x. Which have x. That thing is only integrated. Rest of the things are constant. The thing which have x, because here it is dx. Suppose that here is dt, then only p will be integrated. So here only x will be integrated. 1 upon x power minus 2, x power 2 can be written as x e power minus 2. And integration, as you know, x e power n. So integration when we are going to write, then what we do? N power 1. We increase 1 power here and we put same thing here. एक पावर ऊपर बढ़ा देते हैं उसी हिसाब से नीचे. This is formula for integration. In same way I am going to do it here. Minus q naught 4 pi. Now what is integration of x power minus 2? You should understand x power 2 plus 1 upon x power minus 2 plus 1. So minus 2 plus 1 means x power minus 1. Minus 1 is here. So x power minus 1 infinite to r. Now this minus sign you can take out. Minus minus plus q naught 4 pi epsilon naught k. X power minus 1 you can take down 1 upon x. Right? So q naught 4 pi epsilon naught k. Now add 1 by x. You are going to write upper limit 1 upon r, then minus lower limit 1 upon infinite. 1 upon infinite. Now what you are going to do? Get. It is clear. W equal to Q. You can write like this. 1 upon 4 pi epsilon naught k q naught upon r. This is your W. This is also potential energy. If anybody asks derived formula for potential energy, in same way you can derive. Now potential you want to find out, V equal to W upon Q naught. What is V equal to? 1 upon 4 pi epsilon naught k q upon r. This is formula for electric potential. Again I want to repeat. As you know, very first you put a test charge q naught at point A, then electric force start acting between q and q naught. That is F equal to 1 by 4 pi epsilon naught k q naught upon x square. Now due to this force, they are repelled. This force, by this force, it is repelling this side. But you want to take this q naught from A to B. B is very near to A, that is that distance here. So how much work you are going to do? F into minus df. Because force acting outward, displacement is inward. So minus df. So minus 1 by 4 pi epsilon naught k q naught upon x square df. This is your dw. Now what you want to do? You should integrate both sides. When you integrated dw, why you integrated? Because you want to find out work done in taking q naught charge from infinite to point P. Because at point P you have to find out potential. So you take a limit g infinite to r. That is infinite is beginning, r is final point. 1 by 4 pi epsilon naught q naught or dx. You take in here. This side also integrated, dw integration is w. Now in this side, if you see, only x square can be integrated. So x square of minus x power minus 2 dx. This all comes out because they are constant. Now integration of this, as I told, minus 2 power 1 will increase power 1. Here you have to increase minus 2 plus 1 minus 1 minus 1. Minus will come out, minus minus plus, and limit is infinite to r. So 1 upon x power minus 1 can be written as 1 by x. Now you take an upper limit 1 by r minus lower limit 1 by infinite. Something upon infinite is 0, right? So you get this formula. This is equal to potential energy. Now electric potential V equal to W upon Q naught divided by Q. Q naught will cancel. V is here. This is all about derivation of electric potential. Just now in few minutes I like to do this derivation without integration, but actually nowadays some teachers create problem. That's why I am not telling so many times this. I am going to tell you. See here. Little change I will do in figure. Suppose this was point P, another point we take Q here, and that is at R distance. That is at R dash distance. Without integration, I like to do this derivation. Suppose that again you put a test charge Q naught here, then force F equal to 1 by 4 pi epsilon naught. A charge is put at Q naught. Q naught is put at here at R dash. So FQ. Again, force will act between them. 1 by 4 pi epsilon naught K Q naught upon R dash square. This is force acting on that charge. Now if you take this charge from here to here, from Q to P, then force acting on that, अब charge को उठा के आप Q से P पे रख दिया, then force Fp equal to 1 upon 4 pi epsilon naught K Q naught R square. Now what you do? Work done in taking charge Q naught from Q to P. Q naught from Q to P. How much work done? You have to find out. For finding out work done, very first you find out average force between P and Q. FPQ. FPQ equal to under root FP into Q. FQ. What is FP? You can see here 1 by 4 pi epsilon naught K. Both have. When you multiply inside the under root, it will come out 1 by 4 pi epsilon naught. It is 2 times ना. अंडर रूट के अंदर कोई चीज 2 बार होती है मल्टीप्लाई में. 1 you can take out. Q naught. Both have. It will come out. What will remain inside? 1 upon R dash square into 1 by R square. That you can also take out. How much will come? R dash into R. R dash into, when you take, multiply both of them and take their under root, you will get like this. And when you multiply both of them and take their under root, then when you multiply, the same things will come out. This will come out, these two will come out. R dash square, R dash, R square, R will come out. So this is average force between PQ. Now, work done in taking charge from Q to P. Q to P, how much work is done? Suppose that dW, not dW, W. Work done in taking charge from WPQ. WPQ. Work done in taking charge from Q to P. Q से P तक ले जाने में कितना वर्क किया बेटा? That we are going to find out. So WPQ equal to FPQ into PQ. Into PQ. What is FPQ? 1 by 4 pi epsilon naught K Q naught upon R dash. R dash. Right? What is PQ equal to? PQ equal to R dash minus R. R dash minus R is your PQ. What is PQ? R dash minus R. भाई R dash में से हम R माइनस कर दे तो ये PQ you will get. Now WPQ equal to 1 upon 4 pi epsilon naught K Q naught in bracket R dash upon R dash cancel. Sorry. R dash minus R is here, no? R cancel. Right? So what you are going to get? WPQ 1 by 4 pi epsilon naught K. One more thing which we forget, you should remember that this force will act outward and you are taking charge inward. So force and displacement both are in opposite direction. Both are in, that I will tell you just now. Q naught 1 upon R minus 1 by R dash. 1 by R dash. If suppose that R dash Q point is at infinite, Q point कहाँ होता है? Infinite. Then R dash equal to infinite. Then add that condition W infinite equal to 1 upon 4 pi epsilon naught K Q naught upon R. Q naught upon R. Now what is V equal to in this condition? V equal to W infinite upon Q naught. Again formula is same. 1 by 4 pi epsilon naught K Q upon R. This derivation is especially for biology students who don't like integration method. Again I am repeating. What you did? You have to find out potential at point P. For that you taken another point Q at R distance. And you put a test charge Q naught here. Then when you put a test charge Q naught here, then force acting on that 1 by 4 pi epsilon naught K Q naught upon R dash square. And if we take this charge from Q to P, again work done, force Fp equal to 1 by 4 pi epsilon naught K Q naught upon R square, because now distance is R. Now average force between them, Fp into Fq. It means their multiplication. When you take both the forces inside the root, then those things which are same, those things will come out. This into this will come out. This into this will come, because anything inside the root x into x inside, then you can take x. So similarly I did here. जो चीजें डबल थी that we I taken out. R dash square R dash R square R. Now this is your FPQ. Force between P and Q, average force. So how much work done in taking from P to Q? That is WPQ. Force equal, what is work equal to force into displacement? What is force? FPQ. What is displacement? PQ. How much PQ? R dash minus R. This distance you have to find out PQ. Then R dash minus R is PQ. So I written here R dash minus R. Now you take R upon R dash inside the bracket. R dash cancel, R cancel. Now you will get like this. This is work done taking charge from Q to P. But if you want to take this charge, you want to take this charge from infinite to point inside the electric field at P. So if point Q is at infinite, then R dash equal to what? R dash equal to infinite, and something upon infinite is what? That is 0. If point Q is at infinite, This point is at infinite. Then r becomes infinite. Something upon infinite is zero. W infinite you have this. Potential V equal to W infinite upon Q naught. This is all about electric potential due to a point charge. I hope everybody understands. Any query you write, I will try to remove that problem. But again, I am saying watch on this frequency, right? Then you can see everything clearly. And I am trying my best, and you all listen me and do it carefully. I hope you all will score good marks. See you. Bye.